Okay. Hello, welcome back to a new video here. We have uh, 1.4, oh, my bad, 1.3 estimated limits of values from graphs. So here we have for how to determine something is non-existent or it does not exist. Let me just write out here, it does not exist. It can be notated like this, or you can put unbounded. Or sometimes it will be like infinity, and that's like a very bad infinity, so maybe retry again. Infinity. There you go. So let's get started and start with our first scenario here. So pause the video and try it for, give me a second. Let me erase this x to give it a value and we'll evaluate that value. Give me a second. Okay. And evaluate 6 and the limit of 6 of f of x. This function is f of x. Remember that. Remember to put your function afterwards your limit and after your limit, because let me give it a actual limit. Okay, so give it a try. Pause the video and give it a try. Cause so when you evaluate 6 in this graph, you're given with this, which is equal to 4. So your evaluation will be 4. But it's a jump discontinuity, I'm pretty sure. Someone please correct me in the comments below. So since this is evaluating and finding the limit are different things, but there's some instances where there's a coincidence that the limit is overlapping with the evaluation of the function because it's continuous. There's no jumps, there's no discontinuities, there's no asymptotes. So that's why it would be sometimes the same. So let's continue with this limit as x approaches 6 from the function of f of x. So here, we can skip this one for right now, okay? I'm gonna go to this one as x approaches 6 from the left side. Remember, when you have a negative, think about it as left. You're coming from the positive side and going to the, not positive side, from the negative side towards the positive side. It's not always this instance, but just think about the numbers are getting bigger and bigger. So I gave an analogy on the other video where if you have your two hands um, and with your left hand you make an L. The L, think about it as the limit approaching your thumb. The thumb is the direction, and you can utilize that for your other hand, which it's like an L but like sideways, or I don't know how to explain it, but yeah. But your thumb is pointing to the left. So yes. Oh wait, oh, give me a second. Let me rewrite right. So this, so we're going like this. 4 from the left side. This is left. So it seems that it's approaching. By each increment, it is approaching 6. But it won't equal to 6 for an evaluation because that has already a value. This would be undefined here. So as as x approaches 6 from the left side, it's approaching 3. But here we have this direction. As x approaches 6 from the positive side, each increment it's increasing to get exactly to 3. Well, not exactly to 3, approximately to 3. So your limit will be 3. So let's give it another try. So give me a second. Since these two are equal, that means your limit, when there's no positive here or a negative superscript, that signifies that it's asking for the limit of both sides. So from the left and the right. This. Give me a second. This is asking for the limit for both sides. Negative and positive. But they both have to equal. The negative and positive sides have to equal. So this will equal to 3. Let's try another example. Um, let's see. As the limit, evaluate 4. Give it a try. Okay. So as the as f of x, f of 4, this would evaluate to here. Since there's a hole here, you jump to your continuity. So your evaluation will be 5. We're gonna skip this one here. So for right now, it's most likely it's better to evaluate from both sides first, then you can evaluate this one here. So let's give it a try. The limit of f of x approaches x approaches 4 from the left side. This signifies that it's approaching like this. 4. The axis 4, or the x-axis 4. And it's approaching 2. But here we have from the positive side, or the right side. So we're increasing, and your limit will be for the right side 5. Okay, so let's give it another try for evaluating 2. Evaluating 2. Give me a second so I can write down everything down. Okay, 2, 2, 2. Not last. Oh god. Okay, 2. Be here. There's an asymptote here also. So since there's no exact value for this, the function of 2 or the evaluation of 2 from the function of f of x will be does not exist or undefined. And the evaluation for the limit as x approaching 2 from the function of f of x will be equal to does not exist. I'll explain it right now. These two have to equal each other to give you your both side limit. So here we have as x is approaching 2 from the left side or the negative side. This signifies that it's going like this. So we can say it's going from negative infinity or does not exist or unbounded. Either or should work. Depends on your teacher, of course. And this would be does not exist or negative infinity. But here, from the positive side, it's going like this. Orange colors, so it's not all mundane. So as x is approaching 2 from the positive side or the right side, it's approaching 4. Um, Later on in this unit, you're going to see how we're approaching it. So if here we're approaching 2.01, which would be equal to 3.99. But the more zeros we have, the more it's approaching 4. So yes, that's how limits work. I'm pretty sure there's a more concrete way or concrete definition for limits, but since I don't know if I want that. Since yesterday I was watching a video on differential equations, which that's way out of my limits. So yes, I was learning about delta and epsilon. It's proof writing epsilon and delta. It's like not higher math, so you don't have to worry about it. This is calculus 1 or AB. So here we have another. Oh, just more examples for this one. So if we were to look for the limit of -2, the limit of -2, since it's approaching infinity, infinity, remember, it's not a number, it's a concept. I think so. I'm not a mathematician yet, so I can't be positive. There's people more educated than me, please educate me in the comments below. And this will be infinity or unbounded. Either or will work for College Board. It was said in one of the videos. So it's increasing from the left side and the right side to infinity or unbounded. So it can be infinity, positive infinity, my bad. I didn't mention that. So the limit would be like this as -2 approaches from the left side. It will be infinity I forgot to put f of x in the function. F of x, the function, it's an amalgamation here, so my bad. I'll just move on. I hope it made sense. If it didn't, you can use the comments below. I'll explain it in my best details as I can. I erased these because it was basically it was kind of like this. You can't evaluate infinity in a function, so yes, that's why I didn't include them, and it was asking negative infinity left side. But if you were to do that, negative infinity from the left side of f of x, that will be like negative infinity. No, no, no. It would be negative infinity. It wouldn't, my bad. It would have been 3. Since this is a horizontal asymptote. Don't worry, if you don't understand, this is gonna be for a later lesson. So yes, but the limit of x approaching negative infinity from the positive side of f of x would have been evaluated to 3 as well. Since you're going from here, infinity would be all the way over there. It's not a number, so remember that. But they said that College Board said that they won't ask you for these questions, like f of x evaluated to infinity. So don't worry about it. They'll probably ask you about this one, the the limit as x approaches negative infinity from the positive side. That looks like an 8, so my bad. But f of x, though that would have been 3, and since this is 3, it will evaluate to 3 from the both sides. I forget to say, you can pause the video so you can give it a try. Okay, we're gonna evaluate -7. Evaluating means we're just going to the exact point in the graph. No, that was the best explanation. Yeah. So -3 would have been here. Here. Let me get a much vibrant color. But here. But it's invisible. Sorry for the difficulties. My best. Here. This would have been -7. Since this is an asymptote, we can assume that it does not exist, or undefined. Pretty sure non-form does not exist. Okay, since here is the limit of x approaches -7 from the left side of f of x, we have to evaluate the limit for this. So it's approaching from this side, so it's increasing each time. So it's going to be multiplying and multiplying and multiplying, or it's going to be doubling and doubling since it's an asymptote, or undefined. That wasn't the best explanation for that, so yes. So your asymptote would have been, or this limit would have been equivalent to negative infinity, or does not exist, or unbounded. This color doesn't look good. Okay. Infinity, or does not exist, or unbounded. Okay, for this limit, as x approaches -7 from the positive side from f of x, the evaluation for this limit would have been it's approaching. It's approaching in small increments each time, very closely to positive no, not positive, negative infinity. It's unbounded, so there's no evaluation for this limit. It's just gonna keep going and keep going. It's never gonna touch the -7 because it's an asymptote. But it's gonna get closer and closer and closer, but it's not gonna get there. Okay, since these two are negatives, infinities, we can evaluate it to negative infinity or does not exist. Let's evaluate for 0 of the function of f of x. So 0 would have been 1. Since this is a continuous uh, line, that means our evaluation and our limit will be the same. But I'll explain it in detail right now. In a second. So the limit of f of x as x approaches 0 from the negative or left side. So this direction approaching here, this will be negative, oh, positive 1, my bad. 1. It will be 1. It will be 1. So 1 and 1. Since the limit of x as 0, well, as x approaches 0 from the left side, well, the right side, or positive side, of f of x, this will be evaluated to, the limit will be evaluated or closely approximated to to 1. 1. Since these two equal, they're both going to equal the same for both, the limit of both sides or two sides, this will equal to 1. And for the function of f of 3 will be here. No, it will evaluate to 4, since this is a closed dot. A closed dot means that's your evaluation. But remember, evaluation and finding the limit are two different things. So for f of 3 as f of 3 will equal to 4. Maybe. The limit as x approaches 3 from the left side or the negative side, this of f of x will be, the limit will be 4, since we're getting closer and closer and closer to 3, your limit is going to be approximating to 4. Likewise here, as the limit approaches 3 from the right side or the positive side, it's approaching and approaching very closely to 5. Since these two do not equal, this means there's no limit from both sides. So it's undefined, the limit of both sides. Let's move on to the next pair of questions. Pause the video and try it on your own. Okay. The function of f of x when x is equal to -5, we're gonna evaluate it. So -5, -5 will be here. I circled it. So it will equal to 4. Since there's no jump or uh, jump discontinuity, or this is not open, we can conclude that our limits will be the same as our evaluation. Since we're approaching from the negative or left side, and we're approaching from the positive side, it's going from 0.01, negative 0.1, and it's getting closer and closer to 4. Likewise, it's getting from 4.9999, and definitely it's going to get closer and closer to negative 4. I'm going to preface that it's negative 4. Negative 4. Well, not negative 4, 5, my bad. Negative 5, yes. This is going to be negative 5. Okay. To evaluate negative 1 would have been this asymptote right here. Since it's an asymptote, we can conclude that it's undefined. Fine, or does not exist. Now that we're going to look for the limits, as the limit approaches 1, negative 1 from the left side, it's approaching positive infinity. Or it does not exist also. Since this one does not exist, this means that this one will not exist. But, or we can give it an infinity. So I'm going to go with infinities. It's going to be positive infinity for this one. And as x approaches negative 1 from the right side, or the positive side, of f of x, it's approaching negative infinity. Since I said the properties of limits, if the left side and the right side do not equal, this can signify that the limit of both sides will not equal. So this would mean does not exist. So f of 5 from the function of f of x, let's evaluate it now. Here we have it. So since there's a hole here, this means that it's not gonna exist, or it does not exist. It does not exist, or undefined, my bad. And we're gonna look for the limit for this one from the left side, or the negative side, to make it easier. Since it's getting closer and closer to 5, it's approaching 3 from the left side, and from the right side, or the positive side, it's approaching and approaching very closely to 3 as well on the positive side. Since these two are equal, remember, or properties for limits, I didn't mention any of those properties, but yes, these two, the limits of both left and right have to equal to give you your limit of both sides. So since these two are equal, it's going to be 3. Let's change colors and do number 7. 7. Since this is a closed dot, we can assume that it's it's given as a value. So this will equal to 0 because it's touching the x-axis. Remember, when you touch the x-axis, this signifies that it's 0. And for the limit as x approaches negative, not negative, 7 from the left side will signify that it's getting closer and closer to 7, which will equal to 0, or the limit will be 0. But here, people might get confused with this graph here that we're going to use, and the limit will be 1, but no, the limit will not be 1, since there's no line or graph connecting them with like a discontinuity or a jump discontinuity. This will signify that there's no limit for this one. because there has to be a limit connecting those two lines like this, so like this, or like this. But since the limit or the line is more like this, you can't approach it from the positive side. So that's why it does not exist. Since these two do not equal, the limits will not equal from both sides. So limit of both sides will be does not exist. Let's move on to another set problem. And let's evaluate -3. You can try it on your own, pause the video. -3 will be evaluated as 1. But for your limits, remember, limits and evaluation are different things, but they can be consequently the same. Or, yes, consequently. Just making sure if I'm using the right ones. So we're approaching from the negative side, or the left side. Negative or left side. We're approaching from the left side, and it's getting closer and closer to 2 for the y's. So your limit will be 2. Since these are connected and there's no jump discontinuities occurring, or that's wrong what I just said, so please ignore it. We're looking for as 3 as x approaches -3 from the positive side, so it's going to be getting closer and closer and closer to 2 in near this jump discontinuity. So your limit will be 2. Since these two are equal, your limit will be 2. Let's evaluate for 8. Okay. For this one, we can see that there's no function occurring here, so we can assume that it does not exist. Since there's no function, there's no limit. Remember that there has to be a function connecting everything together to have a limit or an evaluation, so it does not exist. All of these do not exist. So yes. So let's evaluate it for 9. This one can be evaluated. 9 will be -1, but there's no left side limit since there's no graph or function connecting them. Or, like I gave an example early on, which then you have to have a graph like this connecting them like that, or they both have to be interconnected. So it will be -1, and since there's no limit, it does not exist. Since there's no function, my bad, or graph that does not exist. And this one, we can find the limit uh, from the positive side or the right side. As x approaches 9, this will be evaluated for the limit will be equal to -1. But since these are not equal, the limit for both sides will be does not exist. Remember, we cannot substitute infinity in a function, so this will not exist. And positive infinity from the left side, we can. It's hard to say from this graph, but uh, I would say does not exist. It would have been easier if there was an asymptote for this one, but it looks like there is, but it's increasing. So I wouldn't be for sure for these infinities. So I'm just gonna put does not exist. Or actually, my bad. For negative infinity, or for infinity going to the left side, this will actually be infinity. But we can put does not exist. From the left side, since we can't see the infinity x somewhere. Remember, we can't substitute x in a function, so we can't see where it is graphically. So we can assume it does not exist. Since these two or does not exist, we can put does not exist. But this is an infinity. Remember that. But since this one does not have an infinity, it does not exist. And here we have our last practice set, last couple practice sets. Here we can evaluate f of 2. F of 2 will equal to 7. 7 of the function of f of x. So let's evaluate the limit as x approaches 2. X will be approaching 2 from the left side, and x will be approaching from the positive side to 2, which will evaluate 2 for your limit. For negative, for the limit as 7 approaches from the left side, it will be here. Your limit will be here. They should be both connecting, but I am terrible at drawing lines. So it's approaching 8. And the limit as x approaches 7 from the positive side, it will be from this direction. And this will give you a limit of 3. Give me a second. Since this is not an appropriate graph, we can say that it's 4. But to evaluate 7, since these two are open, there's no evaluation, there's no closed section to give it an evaluation for this, so it does not exist or undefined. So let's find the limit for 9. 9 will be here. And 7, the limit would have been 7. Would have been from the right side, or the positive side would have been 4. Okay, 9. As x approaches 9 from both sides, or the left side, or negative side, it will approximately get closer and closer to 3. Since this line is continuous, we can assume that the limit of both sides will be equal. So they will both be 3. Since there's no open or a discontinuity occurring here, we can assume that the answer would also be, the evaluation will also be 3, the same as the limits. So here we have 3 functions. Let me show you graphically in decimals. Give me a second. Decimals. Decimal. Uh, Here you go. Here we're gonna use decimals. So the limit is said that it would have been, the limit says x as x approaches 3 from the positive side of the function of -1 divided by the radical of x, or the radical is square root of x minus 3. So here we have it graphically uh, done in decimals. So as it is approaching 3 from the positive side, remember the positive side means that we're going from positives to negatives, but the right side also. It's the same thing. So since we're getting closer and closer to 3, we can see that it's going closer and closer and closer and closer and closer. It's getting bigger and bigger. So we can assume that this will be equal to infinity. So here we have undefined, negative infinity. Negative infinity. Negative infinity or does not exist. And here we're going to evaluate this limit. It's done already for us graphically on decimals. I already did it beforehand. So it will be this limit. So we're looking for the limit as x approaches 3. So as it approaches 3, it will get closer and closer to 1/4 from both sides until it gets undefined for the evaluation. Since this, we can actually do this algebraically, but that's for uh, a later unit, later lesson. So don't worry, be in tune for that. I'm gonna go over that. So since both of them are getting closer and closer to 1/4 or 0.25, this algebraically will equal to 1/4. So if you know how to do algebraic manipulation, you will get 1/4. I'll show how to do that in a later lesson. And for the limit as x approaches 0 for sine of 1 over x, I have this, I wrote it down here. I forgot to switch scenes on my OBS, but here we're gonna switch it back to decimals with the graphing calculator. Here we have sine. So we can see the oscillation here occurring. And I forgot to include these, or I did include these in the beginning of the video. And I showed them off. But for common types of behavior associated with the non-existence of a limit, x approaches a different number from the right side and of c than it approaches from the left side. So it's saying the limit of x of c left side has to equal to the limit of x c from the positive side. When they're not equal, this means it does not exist or non-existent. And here it's talking about an asymptote. Oh, here we have the pictograms here. So yes, and for the oscillations between two fixed values as x approaches 2. So this, the sine of 1 over x will be does not exist or unbounded. Since there's many they're just getting smushed all together so we can't tell the limit for now. Thank you for watching and I hope you enjoyed the video.